Okay, welcome back. Now in the previous video, we introduced some new key terms, okay? We started looking at the shells of an atom, the quantum shells, and we then started looking at these subshells. Now the next step after that is to look at the orbitals, which is what we're going to do in this video. So hopefully, you'll be able to state how many orbitals there are per subshell, and be able to sketch these orbitals because they have very specific shapes. Okay, so in the previous video we mentioned subshells. If you can't remember this, perhaps you need to look over the previous video again. But basically every shell is broken up into different subshells. Now there are 4 different types: S, P, D and F. Now remember, you only really need to know about the first 3 of these at AS and A2 level. Now, each of these subshells has specific orbitals. Now, orbitals is a representation of the space these subshells take up. So, a definition of an orbital is that there is a 90% chance that your specific electron will be found in that orbital. Now, each orbital has a specific shape, like I was saying, and you need to know what these shapes are and potentially be able to draw them. So let's start with the S subshell. Now, S subshell only has one orbital, and it looks like this. This is the most simple one. It just has a spherical shape around the nucleus, and this spherical shape, this orbit, there is a 90% chance that the S electron will be found in this space. So all of the S subshells from the different quantum shells, they will all look like this. Now as you have an increasing quantum number, so you go from the first shell to the second shell to the third shell, these spheres will get bigger, but they will have the same shape. Now the P subshell is a bit more complicated because it has 3 different orbitals. It has a px, a py, and a pz. Now this diagram here is more along the lines of what you would have to be able to draw, which is why I've chosen it. Ignore the fact that it says 2px, 2py, 2pz. It could be the second one, the third one, fourth one. They would have the same shape. They would just get bigger as the quantum shell number increases. Now if we look in a little bit more detail at these orbitals, you see the first one, px, is along the x-axis. Py is along the y-axis, and pz is along the z-axis. So these 3 orbitals combine to form the P subshell, but each orbital takes up a different space around the central nucleus. And then the D subshell. Now this one is more complicated still. Now in questions where you've had to draw orbitals, more than likely it will be S or P. But potentially you could be asked to draw a D orbital, so we better have a look at them. And these are the D orbitals. There are 5 in total. So you have D, Y, Z, where you have these 4 areas, and they are in between the Z and the Y axes, if you try and think about this in 3D. The DXZ is in between the X and Z axes. The DXY is between the X and Y. Now the bottom 2, which are even more complicated and don't follow the same pattern, the x squared minus y squared. Now these are actually on the X and Y axes. It looks like a combination of px and py, but they're slightly different shapes, slightly bigger as well. Okay? And then the dz squared doesn't follow any sort of pattern. You see some of the space is on the z-axis, but then you have a sort of ring round the middle like a donut. So these are the d orbitals. The d electrons have a 90% chance of being in these areas of space. So, very new, slightly strange, but these are the areas in which electrons normally exist. These diagrams are not representing the electrons, they are representing the space in which these electrons can exist, or 90% of the time at least. So quite short this video, just introducing the shapes. So hopefully you can now state how many orbitals each subshell contains, the S, the P and the D, and you should know the shapes. And hopefully with a little bit of practice you will be able to draw each of the orbitals we have looked at. So make sure you attempt to add these diagrams to your notes, and I'll see you in class.